Unfortunately, and now, and now for something completely different. Still staying on the water theme, I welcome on stage Aybars. He is a PhD student and a research fellow at Norwegian University of Science and Technology. Oh, he has a very long experience working with the, even in the ship engine room and also on the shore. So please, the crowd is yours.
Thank you for the introduction, Bibi. Merhaba. Hello. Thank you for joining us today. I will start my presentation immediately. I will talk about our papers published a couple of months ago by the Journal of Marine Science and Engineering. And I am not alone for this paper. We wrote this paper together with Associate Professor Vasilis Kalos and also Professor Socrates Kassikas. The title of our paper is Towards a Cyber-Physical Range for the Integrated Navigation System. What is the purpose of this paper? We try to understand the requirements of a testbed for the integrated navigation system. What is an integrated navigation system? It is a system and combines the information receiving from different components such as AIS, GPS, ACDIS, and others to improve the safe navigation for conventional vessels. And it includes 6 tasks. These are detailedly described by the International Maritime Organization with some circulars. And the requirements for the collision avoidance and route monitoring is totally mandatory for an INS. Some of the requirements of the navigation and control data and alert managements are mandatory again. And route planning and navigation citations and data display, these requirements for such tasks are optional. Our research consists of 2 parts. In the first part, we investigated the integrated navigation systems in different aspects, such as components, subcomponents, services, communication protocols, interfaces, dependencies and connections, data and data flow. We find a basement for this research because each manufacturer has different viewpoints. Some class requirements has different requirements. That's why we selected the IMO requirements because it is the god of the maritime. And to access the rules, current rules and regulations, we use the IMO Vega database offered by the International Maritime Organization and DNV. In the second part of our research, we look at the bridge testbeds in the literature in different dimensions, such as capabilities and functionalities, hardware components, monitoring and management tools, simulation and emulation tools, architectural models, research analysis, comparison of testbed, and potentiality for cybersecurity of a testbed. And we made a systematic literature review to reach out to relevant publications in the literature. And finally, we found 16 publications in the literature between the 2014 and 2020. Before the 2014, there were no publications regarding the bridge testbeds. And finally, we combined our extracted knowledge with the paper of Towards a Cyber-Physical Range for the Integrated Navigation System. However, in this presentation, you will take more than this paper. Firstly, we look at the components. However, International Maritime Organization doesn't have a component list for an INS because there are several factors, such as the size of the vessel as a volume or as a length, or navigation zone. That's why we look at the relevant circulars, relevant conventions, and we try to find the components as many as possible. And finally, we find 25 components developed for different purposes, such as positioning, such as to receive meteorological information or heading information. And then we look at the subcomponents. IMO defines only the performance criteria, actually. They don't interested in how it works, typically. And for example, ACDIS. ACDIS is an electronic chart, and we divide into 2 groups as a hardware and software. And hardware, monitor unit, processor unit, and control unit. Software, electronic chart, active software and operating system. Of course, you can go deep, more deep. However, for us, it was adequate. And services. Service means functions. And we look at the IMO requirements again to define each component. For one of them is eco-sounder, is to measure and to give the reliable information about the depth of the water under the keel, under the vessel, I mean. Communication protocols. Vessels are communicate with other vessels and shore through the different protocols, through the satellite, for example, or through some antennas. And another story is actually how the components communicate with each other. Interfaces. There is no any interface list for the in terms of the International Maritime Organization. That's why we look at the manufacturer brochures, and we found some interfaces such as Ethernet port or USB port or some ports for the serial communication. Dependencies. We reviewed all performance criteria, performance standards of the IMO for each components. And for example, for the radar, we found that it depends on gyro compass or transmitting heading device, AAS, EPFS is electronic position fixing system. Actually, it is like GNSS system or aileron system, and speed and distance measuring equipment. And finally, we reach out that 7 components depends on different components. Produced data. Everybody knows that GPS give us a position information. However, for the International Maritime Organization, it is not adequate. According to the International Maritime Organization, GPS must provide also time information, speed information, speed over ground, or course information, course over ground. And finally, we made a model for an INS. And in this model, you can see different locations. For example, Monkey Island. It is the roof of the vessel, actually. Or the bridge is the center bridge and with wings. And what about the underkeel? There are some transducers. Also, we try to show some communication protocols between the terrestrial system, between the satellite system. We would like to show the communication protocols between the vessels, vessel to vessel. And we would like to show the position of some components. For example, some antenna units or magnetic compass are in the Monkey Island, but some microphones is the starboard side, port side, bow side, and the aft side. Then we look at the bridge testbeds in the literature, and we found that 2 bridge testbeds are available in the literature. They are developing for performance tests of the components, to develop new technologies, and to make a risk assessment. And one of which is recognized by the IALA. I will mention about what it is. The testbeds are designed as a mobile or fixed. Real components or mimic sensor data can be used, and some tools for the monitoring or 3D creation, it is also possible. IALA. IALA is one of the most important maritime organizations in the world, and it is recognized by the International Maritime Organization. It is granted with consultative status. And EMIR Bridge Testbed, a maritime integrated reference platform developed by Oldenburg University in Germany, recognized by the IALA. However, it is not used for the cybersecurity studies. They have a fixed platform. It's a really large container with some antenna units. There is another container, but smaller one. However, it offers again the mobility. For example, in this photo, you can see that this container is on deck in service. Also, they can move their testbed with some aluminum bags. Another testbed is developed by the Hyundai. Hyundai used the real components on vessels in service. What is the drawbacks for our researchers to find a vessel? Because maritime sector is a conservative sector, and they are not open for the research or for collaborations. And however, for Hyundai, it was not difficult because they construct ships and also they operate ships. And also they develop some technologies. And for a technology developed by them, they use a real vessels. And here you can see their schematic diagram, their test environment. As you can see, there are some real components on board ships, such as AIS, radar, GPS, and other real marine components. Of course, you can use also some simulations in your test beds for different purposes. One of them is environment. What is environment? Firstly, you can need a geographical position, geographical map, and also you need weather conditions. You can create some sea conditions. You can make some scenarios with them. And traffic simulations. You need to create some. You need to put some vessels. Which kind of vessels? Tankers, containers, dry cargo vessels. Which one? And embody simulator. It is regarding the movement of the vessel. It is like through the starboard side, port side, or to bow side or aft side, like this. You can simulate the behavior of the vessel with embody simulator. And sensor simulations, of course. Sensor simulations means IAS simulation, GPS simulations, anemometer simulations, and others. You can create some virtual components. Of course, what is, for example, for the main propulsion system, bow thruster system, some steering system, what is the benefit of the virtual controls? You can carry it easier. Also, maybe you can use a test zone and you can occupy this zone with several components such as AIS system, some cameras, some weather sensors, and you can transmit the collected data through a router to your lab. We tested the bridge command. It's an open source software. Actually, it was first time used by the EMIR bridge testbed. And we found that it acts like a real ship network. Of course, it is too limited. However, it can be usable somehow. And also, you can combine it with some ship controller units as well. And another software we tested, NVA simulator. It actually broadcasts more ship network. However, visualization is limited or limited to compare to bridge command. OpenCPN is an electronic chart. It's used by the amateur seafarers and also some ship pilots. However, you can connect your real components, or you can use some NVA simulator or bridge command to this software, and you can take the NVA messages. You can collect the NVA messages. You can see the reaction of the simulators in the OpenCPN. Another one. During your research, during your study, you can need data sets, and one of them, of course, the AIS data set. And Norwegian Coastal Administration offers their AIS data free of charge through an IP address and port number. Use of bridge simulators, as I remember, the first time mentioned by the Plymouth University, some researchers in the Plymouth University, they also mentioned about the drawbacks and advantages. What is the drawbacks? For example, the maritime departments use the bridge simulators for training purposes. And if you damage their simulators, their trainings will be delayed. And also, these are costly equipments. It is really hard to touch the simulators in terms of, coding. However, it is a ready system, and that's why you don't need active software, for example, radar software. It is ready to use. Geneva University has a huge project actually, and one of them regarding the cybersecurity studies. They're also planning to combine their full mission bridge simulator and cyber range. As I know, still an ongoing project. Taltech also use a bridge simulator for their cybersecurity studies. And now they have another test environment. They are planning to make some research for the maritime cybersecurity studies. Maybe during the coffee time, they can give us more information about their testbeds as well. And NTNU, our university, Marine Department, purchased a simulator for the cybersecurity studies in particular, around 6 months ago. And we started to work on it. I would like to share our initial findings with you. Firstly, it is possible to connect with real bridge components, like AAS, GPS, real components you can combine. And we reviewed the network traffic, and it is compliant with the standards. The another one, we found in the front side 15 different kinds of components. However, when we look at the network traffic, it is less than seen. For example, heading information is provided by the gyro compass on a real ship. However, and in the front side we see the gyro compass. However, when we look at the network traffic, this data is produced by the GPS messages. We are trying to understand how we can create a remote connection opportunity. This is one of the problems, because the Marine Department is different city in the different than us, and maybe a remote connection could be also better for us, maybe also better for our stakeholders. The another one is potential scenarios. How can we create some scenarios using a simulator? This is our next question, actually. And we are trying to understand the combination of the simulator with some tools, some cybersecurity tools, or some data sets. How can we combine them? This is our next question. Thank you for listening to me. If you have any questions, maybe, okay, then maybe you can ask during the coffee.
Right. Before I open the floor to the questions.